Today, the ds-incubator continues on the series about building and publishing Shiny apps, and today I wanted to talk about debugging. Sometimes, or many times, unfortunately, Shiny apps don't work as you expect, and you may encounter basically three kinds of problems. One is when you get an obvious error and you will get a traceback that Shiny prints to the console. A second type of error when you don't get any errors, but the value is incorrect. And a third type of error is that specific to Shiny, where all values are correct, but when you interact with the application, the values are not updated as you expect. So the first two kinds of problems, you use tools that are already in your maybe in your toolkit because they are general to any R, to debugging any R problem. But the third kind of bug is kind of specific to Shiny. So we'll need to probably you can't reuse the tools that you already have. So today we're going to be trying to first learn how to read a traceback, then see how constraining the bug to a smaller section of code can help us understand what the problem is, and also that helps with creating reproducible examples for yourself and for others to help fix the problem. Also, we're going to be debugging with the function browser or the checkpoints in our studio. And that works for a single set of inputs, as we're going to see soon. And then we're going to be debugging also with the, basically by printing messages to the console with the function message, which we can combine conveniently with the glue package. And finally, we'll very briefly touch on this convenient function from Shiny called Reactive Console, which when you set it to true, when you enable that a Reactive Console, you can use the console as if it was a Shiny app. That will allow you to experiment with reactive code before you actually build an application. All right, so let's jump into the motivating example for today. So basically, the goal of today is to create a simple app with an input for users to give us a number, and that number we will use to subset the rows of a data set called cars, and we're going to be printing a table and plotting a plot. So I have a little function in this file called utils.r that I'm sourcing right now. The function is called ×2, and it's very simple. Takes a number and multiplies it by 2. And this is a buggy, well, kind of. So that function, it will expose a problem in our app. So for now, we'll see how it actually does work intuitively outside an app, and then we're going to use it inside an app and see how it doesn't work as we expect. So first, we're going to calculate the ×2 of 6, which should be 12, right? It is 12, and then we're going to use that to ask for the head of cars. So cars is a data set. That is a data frame. Let's call the structure of cars. It's a data frame with 50 rows and 2 columns. Because it has too many rows here, I'm going to be subsetting it with the n value that we got from ×2. So that is, it should give us 12 rows. Here you have the 12 rows. So the app will show this data set, and then it will also show a plot. The function plot in base R knows what to do with this data set because it has only 2 columns, so dist and speed, and plots them showing a scatter plot. Right? That's what we get. So basically, we're going to build an app around this code so that a user that is not necessarily an R user can interact with it from the web browser. So that's precisely the use case where Shiny shines. So we're going to be using this app here. Let me walk you through it quickly, and you may already spot some of the problems, but we're going to pretend that we don't see them, and then later on we're going to try to debug them. So first I'm going to be attaching the Shiny package, then the functions that live in that utils.r file. I put them in a folder called debugging, and here is my utils.r file. And then the UI is very simple. It has a select input call that will allow the user to input a number in this case. Then it has some space for a table and some space for a plot. The server is also quite simple. The plot is here at the end, the table is here in the middle, and the data comes from this reactive value called dataset, which I chose to extract into its own reactive because I'm using it in two places, right? So here in line 16 and here in line 20. So that is the app. So let's see what happens if I run that app. I'm going to press Shift Control Enter, and here we get a traceback error. So on the app, we see that the UI has generated a selector, so the user can select 1, 3, or whatever. But I do get, instead of a table or a plot, I get an error that says non-numeric argument to binary operator, which is an error that we very often see in R, unfortunately. So we also see in the console a traceback. So that is what defines this problem as a problem of the first type, where we here, I want to show here. So remember, we mentioned 3 kinds of problems. The easiest one is the one where you get an obvious error and you get a traceback. And why is easiest? Well, because Shiny will tell us where the problem might be. So we see that in the call to render plot. So notice that the traceback has a bunch of lines, but RStudio is kind enough to highlight the ones that are relevant to debugging. So basically the lines that relate to code that we wrote, as opposed to some of the shiny magic that happens under the hoods. So notice that the problem kind of starts here in line 20 of the app.r file. So let's go to that file, line 20 here, because we are calling in the render plot reactive, we are calling the data set that has the problem. But then that takes us to line 11, which is here. So it looks like the problem comes from ×2, and then it jumps to the utils.r file, line 2 and 6. So we haven't yet seen that file, but we will in a moment. So the first thing I'm going to do is I'm going to I'm going to stop the app, although you don't have to. We could actually leave it running there. I'm going to open, create a new line here just on top of ×2. Why there? Well, I think the problem sometimes arise early in the stack of calls that the traceback shows, and then the problem becomes unavoidable and triggers the error message that you see kind of deeper in the call. But I like to explore the problems from starting from relatively high up in the call stack. So let's start. Now we're here in this file. So let's start from this file, and then we're going to be jumping into the function on the other file. But to me, it makes no sense to start here or here, because I know that there is nothing going on here, and there is very little going on here. Here I'm only calling plot on dataset, and here I'm actually using the datasets reactive. So most likely the problem is in this other reactive, which is a bit more complex. And we already know from the stack that in line, what was before line 11, now it's line 12, the problem, we have to step into that ×2 functions to see what the problem is. So now I'm going to press again Shift Control Enter. Notice that here it says reload app. So when I press Shift Control Enter, the app is going to reload. It's going to stop the execution when where I typed browser, and it's going to give me a console, which I can use now to do whatever. In particular, I'm going to be using it to enter shortcuts for these commands at the top. So next is you can click here on next or type N and then enter. That will kind of move to the next line in the Interactive Debugger. And if you want to step inside a function, which is you can either click here or you can also press S and then enter. So that will step into the ×2 function. I'm going to press next to go to this line. Now I see that ×2 calls G. Let's step into G, and now let's go next to get to line 6. Now let's step into H, and now let's hit N to get to line 10. And now there is nowhere else to go, so I better run this code. If I highlight this and hit enter, what I get is the error that we were seeing from the app. So obviously the ultimate, the last place where the problem is exposed is here. So let's see what X is now, and that is what is interesting to me. So X here in the console, right, is this literal value 1. So if I say the type of X is a character as opposed to a number. So if I do 1 plus 1, that will work, but if I use literal 1 plus 1, that will give me the error that we see. So obviously the problem is, we identified, is that the to stop execution you can do capital Q, or you can hit that red square that you had up there. So the problem is obviously that the input that Shiny gives us, once the user enters a number through the UI, Shiny takes that as a literal string and not as a number, right? So if you want a number, you may use a different function, not select input, but numeric input, for example. But that's fine, because we can still use select input if we convert that number here to that string to a number, which we can do. But before we do that, we could also attack the problem in a slightly different way. So I'm gonna first again trigger the interactive debugger, because I would like to be able to kind of come here and like highlight code, press Control and Enter, and print stuff to the console. So like work with this interactively. So here we have that that call to ×2 that makes my app a lot more complex than it actually is to expose the problem. I would like to see, for example, what would happen if instead of ×2, I just say, hey, okay, let's forget about everything that happens in the file utils.r, and let's just print. Let's just pass the value input.n directly, right, to the app. So let's explore that thing. This is a simple strategy that is very useful. The idea of, okay, if the problem, what happens if you shrink the problem to the minimum amount of code that exposes it, and what do you get, right? So that is helpful in, for example, building reproducible examples that you may want to share with other people, and as opposed to kind of sharing a huge app that they made to kind of navigate to find the problem, you just send the tiniest bit of code that exposes that problem. That you will get a lot faster help. So in this case, by removing this line 12, I'm basically removing anything that lives in this file utils.r, because that's the only the only function that this function is all the code that lives in that utils.r file. So, but this is simply to say that this is one strategy to solve problems, just to reduce the size of the code that you're working with. So what would happen if the input n is passed to here? Okay, what you get is let's define this. Let's go to the console, and the app is running. This is unexpected. Let me see. Let's go step here. And okay, I think my console is getting confused with the n that comes from so it's getting confused between the n that is here in the code and the n that you press to move, basically the shortcut for next here. So instead, what I'm gonna do is I'm gonna move the input n inside head and see what this prints. So notice that if we print input n and is 1, we still get here, we still get let's actually call it a different value, n input n. Hopefully this will help. N. Okay, let's see if this helps. Okay, yes, this does help. So now what we have is a smaller app, and I'm going to show how changing the value, how we what approach that we can use to change the values from the UI and see how that changes code in the server side of the app. So far, with browser we can only see what happens with a single input. In this case, we trigger the interactive debugger with the input 1, and now input n is always going to be 1. Even if I change here to 4, for example, or 6 or whatever, still when I print input n, I still get the number 1. So I would love this to be different. I would love to see what happens as I change the inputs here. So for that, I'm going to be using a different tool, which is message, and I'm going to combine it with the glue package because it's very convenient. The input is, I'm going to say input n, the class, the type is type of input x, n. Okay, so with these messages here, and I can now remove the call to browser, what I hope to do is to try and understand what the app does on the server side when I change the inputs from here. So notice how, okay, so now by having removed the line that calls times 2, which was kind of buggy, now I get this plot to display at least. But notice what happens when I change the values here. So when I change to 3, these calls to message that I wrote in lines 12 and 13 produce this output here on the console. So I can now confirm that the input is effectively 3, but the type is still a character. Also notice that okay, the values are kind of correct, except that the type of the input should be likely a numeric. But it doesn't seem to be a problem because the plot so far seems to be working just fine. I see 3 dots there, suggesting that this is working fine. But what happens if I do 6, for example? I expected only 6 points there, right? Because the number 6 could be subsetting the cars data set to only 6 rows. And then I would expect that to be the data set that is plotted, so that I would expect only 6 points. But instead I see a lot more. So that is the second kind of problem, where you don't get an error. For some reason, the head function is able to work with a character, this one here. So it's able to work with the input number, the input 6, even if it is a character as opposed to a number. But the behavior is different to what I expect. So here is the issue, right? So you don't get any error, but the value is incorrect. The value in this case, the incorrectness of the value is exposed by the odd plot that we get. So obviously head is not doing what we think it is doing. So let's confirm that. So if I do head of cars on the console, if I do the number 6, it does subset to 6, but if I do the literal string 6, it doesn't, right? And it does not throw any error. So this is the case. No error, but the value is incorrect. So second type of problem here. And how you tackle that problem? Just by interactively, querying your code and noticing what's odd. In this case, what we notice that is odd is the type of the input. So the solution to that is, of course, that we want the input to be a numeric. So we can do as numeric, right? And with that, so if I do this, so I convert it first to number, and then I use it to print the message and to create to use it in to create the reactive data set. Okay, so let's run that up. Let's see what that is happening now. So now the input by default, it starts with 1, and it's now a double. It's no longer a character, so that's good news. Let's see what the app looks like. Okay, with number 1, it works. We still don't see the plot, and that's another problem that we're going to be tackling next. But then the problem was exposed when we click 6. So let's see what happens now. So let's see if the problem is solved, and it is. So now we see 6 points as opposed to a lot more that we saw before. So we have solved that problem of type 2, by which at some point we were getting no error, but the value was incorrect. So now the value is correct. We're still left with this last problem here, which is that there is a value, in this case a table that is not being updated. So we created in the app a space for a table, and that table is not showing up as we change the inputs here. So that's the next point that we're going to tackle. But before that, I'm going to, now that we know how to fix the problem, which was with this call to as numeric, what we're going to be doing is applying that solution to the entire app. So now we're going to reactivate, basically we're going to get rid of this code that we wrote here, and we're going to reactivate this to use the entire app, and we're going to solve the problem in the way that we learned we need to solve it, just by calling it as numeric. Right, so we're going to do as numeric the input, and only then we're going to be doing ×2 of that input and then the head of it. So now I can change this to n, and let's see how this goes. So again, now I expect that error to not show up here anymore. No more messages print to the console because we have removed that those calls to message. So here is, or is it? Let's stop the app for a moment. Let's restart because that was an unexpected output. Shift Control Enter to trigger the app, to run the app. This is taking a second to restart. Sorry for the wait. You're not good. Looks like my RStudio is kind of getting stuck. I may restart the whole project. Let's see. Let's kill that process and let's start again. DS shiny. There you go. Sorry for the wait. Let's see, need to wait a few more seconds until it is the freshest. Okay, so let's go with my app.r here in debugging. Let's start this up with Shift Control Enter. And what I wanted to show is that there is no more traceback, so no more error of type 1, no more error of type 2, which was the error by which you get no error but the values are incorrect. So if I do 6 here, now I should see only 6 values. No, actually 12 now, because I'm using the ×2 function, so 12, and that's correct. But we are still left with the problem of type 3, which is this idea where everything seems to be correct, but the app does not update as you expect. And that is what we are referring to here, is that we created space for a plot here, right? And we created that plot here. Oh, sorry, a table. We created a table, space for a table in line 6. So between the inputs and the plot, there should be a table here that is not showing. And here is the table. We created it, but it's not showing. So what is the problem? Well, this is a problem, again, specific to Shiny. So some of the knowledge that you bring from debugging R in general may not apply. And a lot of the times, in my experience, if this kind of thing happens when you just don't see an output, is simply because the connection between the UI and the server is broken. And the only connection that there is between these two functions is the ID, the input ID. In this case, the input ID is table, and the reason why it's broken is because it is with a lowercase t on the UI and a capital T on the server. This is not an error from the perspective of Shiny, but it is from the perspective of the intent of building a functional app. So if I change that t to a lowercase t and rerun the app, that should fix that problem of type 3. So let's see, and here we are. So we choose a number, the function times 2 duplicates that number. So we see with an input of 1, we see this table with 2 rows, and we see a plot with two dots. And if we choose the number 6, we see 12 rows, and we see a plot with 12 points. And that has effectively fixed our app. The last tool I wanted to talk about is, let's stop this app, is the Reactive Console. So a lot of the times, to experiment with code that you want on the, you would like to, write add to the server something like this, right, as numeric, something like this. So how could you do this? How could you explore this code if you don't have it already in an app? Okay, you can build an app around it, but it's it's very annoying. So if you just want to explore, especially in the early stages of building an app that you're kind of trying to figure out what you want to do. So one useful, so let me first show how this won't work. So say that I have, I'm working with this code, and let's say, okay, this is the number 6, the literal 6, if that was the input, and say I want to explore this, right? So I run this first. What I would do is attach Shiny, right? Because reactive is a function of Shiny, so I need it. And I can run that code, and that's fine. But if I wanted to use it as I could inside the server just by calling dataset, what I get is that error that tells me that that function, or that reactive dataset, has to be used only in a reactive context, and we don't have a reactive context. So again, you don't want to build a whole app just to explore something that you may throw away. So the solution to that is to call, it's also a function from Shiny, it's called Reactive Console, and you enable it by saying true. So with that, then you can run, let's see if it ran that set. You can run any reactive on the console as if it was a Shiny app. So without actually building the app around it. So that would allow us to explore things like what we're doing here. That with if this is if this literal string is converted to numeric, it works as you expect. But if it's not converted to numeric, then it won't work as you expect. And this exploration, notice how we are doing it outside the reactive context of an app, but instead we're creating a reactive context simply by using that function from Shiny. It's called Shiny. It's called Reactive Console. Right, so we say true. Right. So this is another tool that you can use to mostly to avoid bugs, because if you explore interactively the server code outside an app before you actually write the server, you have better chances to write it correct the first time. Okay, so that is what I wanted to show today. With that, we have, as a summary, we have covered 3 kinds of problems that you may encounter. One by which you get an obvious error, another one by which you may not get an error, but you don't get an error, but the values are incorrect, and a third one by which the values are correct, but the app is not updated as you expect. So the third one is the only that is specific to Shiny. The other 2 are problems that you may have solved already in R with other tools. From the tools, the ones that we discussed today are, debug, browser, the function browser, which allows you to fire an interactive debugger. That's terribly useful in any code, whether it is the UI or it is the server. Once you do that, you can only interact with the inputs that were passed when you fired the debugger, meaning that you won't be able to see, how the server, changes based on different inputs from the UI. Instead, if that's what you want, if you want to explore how the server changes with different inputs, one strategy is to print messages to the console using the function message, which you may couple with the glue package to write very easily the messages that you want to be printed on the console as you interact with the app from the web browser. And then you'll see how those values update. And then finally, the other tool that we explore is this function called Reactive Console in Shiny that allows you to transform basically your normal R console into a reactive console, meaning that you don't need to build a whole app just to explore a few reactive values that you're interested in. That's all for now. Thanks.